My presentation will be the first presentation on a new book which will appear in February late next year on sea level history of humankind. I'm afraid it's in Dutch, but maybe there will be translations, as the other books have also been translated so far. So that's what I'm going to tell about, and what is actually, well, yeah, okay, that's us, that's we, that is the first anatomically modern human found in Ethiopia. It is about 160,000 years old, so that's actually where our history as Homo sapiens starts. It has been found in Ethiopia. We will not speak about that country, but we will try to understand what sea level change has meant for our own species during the time that he is living. So we are not going to go back to the times of the dinosaurs, we are just going to speak about Homo sapiens and sea level. Come on. Yes, okay. So what did we experience, our species? 160,000 years ago, and it's in the left of the curve that you see, then we were still in the penultimate ice age, the last but one ice age. That was when Wageningen was covered by a big ice sheet at that time. That's when Homo sapiens more or less originated, but not here, but in Africa, of course. After that ice age, sea level rose very quickly, and it rose so fast, it rose even up to higher than at present. It rose to 6 meters above the present sea level. And that period is called the Eemian. The Eemian, or Emia in Dutch, is called after the river Eem. And I will concentrate on that specific period during my talk. And you see that after that, sea level was falling again until 120 meters lower than at present, when the North Sea was dry. And so on that is in the fullest part of the last ice age. And at the end of the last ice age, about 20,000, 18,000 years ago, sea level started to rise very quickly again until we get more or less to the present sea level. But I will not speak about the present sea level. I will concentrate on that early period of the Eemian, about 130 to 120,000 years ago, when Homo sapiens was already there. That is the talk I want to give to you. Eemian, it was called Eemian after the river Eem. Here in the Netherlands, you see it in the upper left corner. That river was studied by Pieter Harting. He was a geologist, and he had to make water borings in the what we call Gelderse Vallei, so in the Gelder Valley, a little bit north of Wageningen. And there he found at 12 to 6 meter depth, he found shells. And he said, well, this is a new period, this is called the Eemian. So he was in 1874 the one who coined the term Eemian, and since then it's being used all over the world. And thanks to Pieter Harting, who you see at the left, at the right hand corner, up corner, you see, he is the one who invited this term. And the first sea level curve for the Eemian was made by Waldo Zagwijn. That was a palynologist, a man who was specialized in the pollen grains of fossil plants, and he could see who vegetation was changing, was getting more brackish and so on. And that is the curve you see at the lower left, and his portrait is on the lower right. That might be a little bit strange that you have to find it by boring, because sea level was 6 meters higher. That was what the Netherlands looked like in the period of the Eemian. The point is, the Netherlands is subsiding, and because Netherlands is subsiding, the 6 meter higher sea level is not found above sea level anymore here. It is in the depth, in the Gelderse Vallei. You can find it back as the shells that Harting has found. So what you see here, actually, that's what it looked like in the period that sea level was 6 meters higher. Then you see a large part of the Netherlands was flooded, and even Wageningen was flooded at this moment, close to Wageningen. People are also afraid, they're always afraid that we will have Amersfoort at sea in the following period when sea level is rising. But actually, this is a fact of the past, not only a spectre of the future. Amersfoort has been at sea, and Wageningen as well. So this is the map that you should have had when you came to study here 120,000 years ago. That is the situation, but we will not we don't know anything about that period in the Eemian people in that period of time. We will have to go to places where the +6 meter level is still preserved, and that's in many places in the world. This is a very fine example from the northern tip of Normandy in France. You see that flat swatch of terrain close to the coast, that flat surface, that was where sea level was during that last high stand of the sea, 6 meter higher. So that marine terrace, as we call it, that is a very nice indicator of where sea level was at that time. In France, the coast is not subsiding as much as it is here in the Netherlands, so it's more or less in place. And we know quite exactly the age also of those marine terraces, because you can date them. All over the world you find terraces at 5, 6, 7 meters above sea level. And this is a coral terrace on the island of Aruba in the Netherlands Antilles. And there you see it is also at a completely different spot. It is also 6 meters above sea level. But this terrace consists of coral, and coral it can be dated with the so-called uranium thorium method. You can exactly determine the age, and people have done that not only here but in Barbados, in Papua New Guinea, in many areas of the world, and they all give an age around 130,000 to 120,000. So that's a very clear indication that sea level was about 5 or 6 meters higher than at present. Now, how do we know what people did when they survived? Apparently they survived, otherwise you wouldn't be sitting here. Huh? How they survived 6 meters higher sea level than at present. Huh? Therefore, we have to go to the Channel Island of Jersey, and that's one of the 2 case studies I will just discuss here. Island of Jersey, belongs to Brittany, but to Great Britain, but it is on the coast of France. You can see it in the upper right corner where it is exactly located. Very close to the coast of Normandy, but it is an island. It is one of these fiscal paradises within the European Union, within the European Union. And that's a very important place because it's a place where archaeological excavations have been made. In the right of the picture, you see again this 5 meter, 6 meter Eemian terrace that we have seen in France and in Aruba already. But you see on the left side, you see a big hole, and that hole is an archaeological site. The Neanderthal people have lived there, or at least they used the cave that's present there, and that cave is a very important cave because you find all kinds of remains of the people at that place, skulls, but also mammoth bones and flint tools and all kinds of different things you find in the sediments that are have been excavated there already from the beginning of the 20th century. It's La Côte de Saint-Brélade, that's what it's called. It's half French. Huh? This is the cave as you see it. There's no excavation going on when I was there to have a look at it. It is shielded for a future investigation. That's the weights are hanging there to prevent it from collapsing. But recent work has been done in the western part of the cave, which is not very well visible here. So what did they find there? Huh? Teeth of Neanderthal people. Huh? There's a very nice museum in Saint-Hélier, the capital of Jersey, where you can see it. There's a scientific community called the Société Jersiaise, and they have made a wonderful museum with all the recent finds. These are 3D electron microscope photographs of a few of the teeth that are there exposed in the museum. So that we know that it is Neanderthal. We can see it also from the type of skulls and so on. Now this is a very important picture because this shows exactly what has happened in that cave. At the bottom you see the granite in which the cave has been developed. And then you see first on the left and middle side, you see deposits from the last but one glacial time. It's the period when it was still cold, when the ice caps were in Wageningen. People were sheltering here for the harsh climate, and they made their flint tools, and they made, they slaughtered animals. There's even a story that this big rock was sometimes used to chase the mammoths up the rock, and then when they had no place to flee anymore, they fell down on the beach, and then they could slaughter them. It's not sure that this happened, but it's one of the stories here. And you see, but if you follow the layers in the left part of of the stratigraphy, then you see the lower part, you see the people have flint tools. Flint, or vuursteen in Dutch, is a very splintery material which is very nice to make tools of, because it's sharp if you cut it. The most flint, or chert it's also called, is found in Cretaceous rocks as nodules. I will show that in a minute. But at a certain moment, you see that they stopped using flint and they used another material. They started to make quartz tools, and no flint anymore. That's very strange. At the last end of the last but one glacial time, they suddenly changed the material from which they were making their tools. And we see also the thick line that is there. That is the line that was formed when sea level was at its highest point at the Eemian, when it was 6 meters higher than at present. Then the water came into the cave and eroded the whole sequence. That's what you see. It's written there, Eemian Cliff. You can see very well that as a result of that, the whole sequence was eroded. And you can also see that there are granite pebbles which are lying there, which were the tool to erode the underlying rock surface, and also the deposits from the last but one glacial age. Then, when sea level dropped again, after the Eemian, after the 6 meter high stand, new deposits were deposited there. We find again much traces of people and skulls and so on and so on. And we see they start to use flint tools again. So why did they start to use first flint tools and then quartz tools and then again flint tools? That is the question which is crucial to the understanding of what I'm here saying. Here you see left, you see the flint tools, and right you see the quartz. Quartz is a little bit more difficult. It doesn't split so nicely. It can be sharp surface, but it is less reliable to make good cutting surfaces. And you can see that for the form of the tools they made. Now this is a geological map of Jersey and the surrounding area of Normandy. And the important point is that where did the people get that flint from? Because nowhere in the island of Jersey you can find any flint. Not in the rocks, not in the pebbles on the beach. There is no flint. But they used flint. So where did they get it from? It's a very strange thing. So the only place where you find limestone with flint nodules is on the Normandy coast. But yeah, it is quite a distance still to get there from the coast to the island. They certainly didn't swim or used boats to get their flints from the mainland. The point is that at that time, when sea level is low, then the Jersey was joined to the Normandy mainland. This is the type of material you find as pebbles on the present beach of La Côte de Saint-Brélade. Just granite pebbles. There's a lot of granite on the island, also some sandstones and shales, but no limestone with chert pebbles. And granite, of course, it breaks very unevenly. You cannot make a tool out of this. So what did they do? They couldn't use this. So where did they get the flint from? So this is what they need. This is the coast of Normandy. Here you see the flint. If you have been there in Étretat or in Chesil Beach, you see this enormous noise of the flint pebbles that go to and fro. And you see from the patina on the pebbles, that on the tools, that they used the pebbles and they didn't take the nodules from the limestone, what you see in the upper left corner, but they took the pebbles from the beach somewhere to make those flints. But there is no flint on Jersey. So what happened? Well, this is what you see in the Ice Age. When sea level was low, Jersey and Normandy, they were connected. And the flint is not occurring on the island, but it is occurring under the sea. This is actually the main story of it. When sea level is high, let's start with sea level is low. They find flint on a submerged beach. A submerged beach which is now 20 meters underwater. So as soon as sea level drops beyond the 20 meters, it has been much more of course, then they could walk to the flint occurrences. That's what you see in the upper figure. And then sea level rises, and because of sea level rise, the flint is transported a little bit to the coast, but the soft rocks which are underlying the flint make some kind of nick point between the flat surface and the steep granites, and then they cannot move further up. So if sea level rises any further, all the flint is submerged, and they cannot get any flint anymore to make their tools. So when sea level rises, they have to find another source, and they found quartz on the island itself, and they used quartz. And when sea level dropped again, after the high stand, they could reach the flint again, and they started using flint again. So that's a wonderful story, because it shows that people have adapted their resources to changing sea level. That's why I like this story so much. This is the quartz in pegmatite veins you see in the granites, and it's not so easy to get it out. The pink is feldspar, it's about 3 centimeters, and the white is quartz, but you see it is splintery, it is good material to make tools of, although not as good as flint. So people have apparently adapted themselves to sea level change. That is the essence of this story. And the second example comes from South Africa. This is the Pinnacle Point cave. It's also an archaeological site. I have been there during my holidays last month, and this is also a very famous site. This is not Neanderthal, this is Homo sapiens, probably one of the places that Homo sapiens has originated, because the oldest age he found here, in this place there's no human bones unfortunately, but the oldest age is exactly 160,000, just like in Ethiopia. And here we have actually a similar story. This has been excavated by Curtis Marion, that is an American archaeologist who with a huge team has been working here. He wasn't there when I was there, it was just a golf course. I had to call the archaeologist to be able to let in, but there is a very extensive work and very thought-provoking and very innovative. The real deposits I couldn't see when I was there last month, because they are covered by the tarpaulin you see in the lower left corner, and it's all covered with sandbags to prevent anybody from coming in. But this cave has also given a wonderful story. Curtis Marion has made a lot of YouTube videos. You can, if you would see what he would have done, you can hear himself. This is just a still from his excavations. What you see here, and this as well is a bit Australian, South African, Italian, French people. A huge team. They published most of it in 2010, but they started in 2000 and they thought we need 2 years to excavate it. And they are still busy because it is 14 meters of human settlements and on all kinds of different things. This is the kind of material as it looks like. There was a loose block lying, so I had some idea of what it looked like, this material. You find bone fragments there, apparently from mammals that they have eaten it at some times. And you find shells, and shells are important. You see the white contours of a shell on the left part of the graph. Shells were apparently eaten by those people 160,000 to 230,000 years ago. And the important thing is there are 2 types of shells that are found in this archaeological site. The first one is the shell that you see at low water at the same rocky point of Pinnacle Point. At low water, then you see a cover of black mussels. You see in the upper right corner, you see the black mussels. And in the upper left corner, you see how the sea is roaring, or the surf is playing around. And so this is all on Table Mountain sandstone, which continues further east along the coast. That is the black mussel. And there's another type of mussel, which is the white mussel. And the white mussel has a completely different habitat. It lives in sand in the sea, about just a little bit below the surf line, the coastline. It's still known. Some people who want to collect those white mussels, you have to walk until your hips, more or less, in the water, and then feel with your toes. And as soon as you feel that there are some shells, and so you have to reap them very quickly, because otherwise they dig deeper. They don't want to be disturbed, of course, and so. But that is even now fisher communities, they take those shells. And if you look what they have found in the archaeological excavation here, is that there is a certain change in the diet of the people in that area, depending on sea level change. This is the first graph, and you see it starts about 160,000 years. The high sea levels are on the right, and the low sea levels are on the left. You see, and in 160,000, that's the oldest age that they have. It was made actually that ate on a barnacle, the type of barnacles that you find on whales, on humpbacks. The white spots on the humpbacks on the big whales. Apparently they used those whales as well because apparently they have made it. And you see also that between 160,000 there was a little bit higher sea level than before and after it. And there you find shells, the black mussels you find from that period 160,000 years ago. After that you only find mammal bones. No shells and so, because sea level was too low. If the sea was more than 10 kilometers away, there's the Antonietta Gerardino, who published this paper, found out with fisher communities that if the sea is further away than 10 kilometers, they don't go for it, they just take what the land is giving. And that's exactly what the vertical stippled line is indicating. If sea level is so low that it is beyond the reach of the people, they don't find these shells anymore. And then we see the second red arrow you see further up, that's the highest point, the Eemian sea level. That is again, you see there, taking the black mussels again, they're finding the black mussels. If the sea is getting to the rocks, then you can find the black mussels. If sea level is lower, or farther away, then the black mussels die because they only need the surf. If there is no rock, then you cannot reap them. And after this high stand, you see that they suddenly changed to white mussels. Apparently, there was a beach which has formed. Sea level didn't fall so quickly after the high stand in the Eemian. A beach was developing, and then suddenly you see coming in the white mussels. And so you see that at the first high stand, they had the black mussels. In the period between that, they just ate buffalo and zebras. That were the kind of animals that they were grazing there in the sea, in the coastal plain, which was evacuated by the sea. And then again, after the Eemian, they started to eat the white mussels. So they adapted their diet to sea level change. And this is a picture in which you see how far the sea was away in the deepest part, in the coldest part of the last but one ice age. You can see that it is almost 100 kilometers from the present coast. People don't go there to collect shells, but 160,000, then it is quite near the coast at present. And in 130, 120, in the Eemian, it was 5 to 6 meters higher than at present. And of course, they had enough resources to get the mussels, but there was one problem, that some of the caves that are there were flooded, and it's not sure that they could get at this particular cave at the very high stand of the sea. But again, here we see people adapted themselves to sea level change. So my conclusion is both Jersey Neanderthals and Pinnacle Point Homo sapiens adapted to changing sea levels. So why couldn't we do the same thing? That is my point. Keep calm and adapt. Thank you for your attention.